Hi everybody, I'm Tommy Clayton, an OpenSciEd middle school teacher and writer. Here to share lesson 8 with you today. This is from unit 8.1, the contact forces unit. And this lesson is really, really important for motivating the work that we're going to do in the next lesson. The first time I taught it, I sort of missed how important this was for the navigation into the work that we're going to do, helping kids to understand friction and air resistance. And so I'm hoping today this video will help you see how important this is to set up the next lesson. So let's take a look at this lesson. So let's remind ourselves how we got here. In the previous lesson, we were really interested in investigating how mass and speed affect kinetic energy. So changing mass or changing speed, how does that relate to the amount of energy? And we discovered there are some relationships that changes to mass are linear and changes to speed are quadratic. And so in this lesson, we're actually wondering well, where did the energy come from that's in this launcher system? And then where does it go after we have all these collisions, like when the box and cart collide and things like that? So let's take a look at this lesson at a glance. This lesson is an investigation lesson. It's a one-day lesson that it will take you about 20 minutes to set up for. There is no hands-on investigation. It does not require students to have devices, and there are no additional related videos. So here's the lesson at a glance. We navigate in. We construct some individual explanations about the energy transfers that may be happening. Then we come together to develop a consensus model of those energy transfers, really breaking down what's happening moment by moment. Then we construct some individual models, and then we navigate out. And so those last three steps there, we're going to really dig into those and talk about those key moments in the lesson. We figure out that the more force you apply to an object, the more that object speeds up. That if you have something really heavy, you need to apply a lot more force to get it to go the same speed as something that is less heavy. Potential energy is something that can be stored in some systems, and that can happen when you change the shape or arrangement of objects. So in our case, squishing that spring. And it is the contact forces that are actually transferring the energy from one object to another or from one subsystem to another within our system. So let's take a look at a couple of the key moments. These are the real important parts that I want to highlight here for you to help you make sense of what's happening in this lesson. So in part 3, this is when we come together and we make this model. You can see that on the screen where we really consider these different moments in the cart launcher box system. So we consider what's happening before the cart is launched when that spring is squished. We consider what happens as soon as that spring starts to decompress and hit the cart, and then what happens when the cart's traveling down the track and then ultimately hits the box. So here we're tracking that energy at each moment. We're saying things like the launcher has all sorts of stored energy. The cart currently has no kinetic energy. The box currently has no kinetic energy. So we're quantifying energy in terms of amounts, but we're not using numbers here. We're just thinking about does it have a lot of energy? Does it have all the energy? Does it have some of it? And what's kind of happening there? And so we use a couple of different ways to do that. We have these little triangles that we write on to show how much energy something has at a given moment. We use these red dots to indicate where there are contact forces or collisions. And then we use these little arrows to show that something is transferring energy to something else. And this is where we start to really see those transfers of energy and how the contact forces are responsible for actually transferring those energy from one thing to another. Now, here's the big thing I didn't quite realize is what this is setting us up for is to really puzzle over what's happening at the end. When everything stops and there's no energy, we really want to set the kids up to puzzle over where that energy goes. This is going to motivate us to find out more about friction, about surfaces and air. Okay, so that happens in the next part, but I want you to be thinking about that as you are developing this model with the kids. So after we do that consensus model, we actually return to adding some contact forces. So we model what's happening separately, and we return to those force diagrams from lesson 5 and lesson 6. And so we focus on those moments where there's the collisions, and we draw those force diagrams for there. So you're looking for kids just to show that equal and opposite forces in those moments, those force pairs. And there are 2 questions here that start to ask kids to focus on what's happening with the track where the cart and box are in contact, and the air. So we're starting to motivate the wonderings about friction and air resistance. Now, in part 5, when we close this lesson and we navigate out, we actually assign some home learning. And so this home learning gives students the option to investigate either surfaces or interactions with the air. So they're going to do they have the option to pick from one of 2 different investigations. There are handouts that go with each that guide the students through these investigations at home. These are very simple, straightforward investigations. The one where they're testing the surfaces, they're simply going to drag a shoe across different surfaces in their home using a rubber band, and they're going to measure how much that stretches out. And then the other investigation with air resistance, they are going to take 4 note cards, fold them into different shapes, and then drop them and record how long it takes them to hit the ground. Okay, so pretty straightforward in terms of the procedure, and the materials are very little that they need. So after this lesson wraps up, where we go is we really start to dig into what's happening with friction, right? Kids have probably been throwing around this word friction a lot in this unit. And here's where we're actually going to figure out like what that actually is, along with air resistance, right? So we're going to do a bunch of investigating to figure out where the energy actually goes and be able to explain fully where all of the energy went. And we're going to introduce how the track and the air ultimately interact with things when there's a collision. All right, let's talk about some tips and tricks for this lesson. So this poster you're going to pre-make. You don't have to make the poster step by step with the kids. You can pre-make this poster and you can reuse it class after class. You're going to pre-make the triangles as well, and you're simply going to put those on and take them off in between classes. Same thing with the key. All of this, you're going to reuse this for every class. So once you make it once, you're good to go for all of the other classes. When the kids are doing the investigations at home, if they do the surface investigation, it does include a paper ruler in the handout. So you don't need to supply the kids with rulers. They can obviously use a metal or a wood one if they happen to have one at home. But if they don't, there's a paper one included for them to measure how much that rubber band stretches out. And so the best way to really prepare kids to do this at home is to just hand them 4 note cards with a rubber band around them. That way they could pick either investigation. They'll have all the materials that they need. If you try to hand students just a rubber band or just note cards, likely they're going to get lost between the time school ends and the time they get home. You may want to also consider you do the investigations and film the data. We know that kids sometimes struggle to do home learning, and so you could also offer the ability for kids to come in and maybe watch those videos before the next lesson. We are going to use the results from these to sort of help us in the next lesson. So videos could be helpful for students that can't quite tackle the home learning. There's a couple words we are introduced into this lesson. One is stored energy or potential energy. Another is air resistance and friction. Air resistance and friction are mentioned at the end of this lesson. We will come back to them in the next lesson and really add them to the word wall and make sure we have a good understanding of those definitions. We create one poster, which is the poster where we're tracking the energy. And we're going to come back to this in the next lesson and update it. So as we find out more about friction and air resistance, we're going to add that to this poster. So you want to make sure you hang on to this for the next lesson. All right, that's going to do it for us. I hope you saw how this lesson is going to set us up to really wonder a lot about friction and air resistance. The tracking of the energy serves the ultimate purpose of puzzling over, like, where is that energy at the end of this? And I think you're going to see the kids get really puzzled over it, but they're pretty sure they think it has something to do with the surface and the air resistance. So you're going to see this lesson really sets them up nicely for the next one. Come back and join us for lesson 9, and we'll see how this all plays out. Thank you.